we have a disabling number system, which is the result of having 10 digits on our hands. We have 8 fingers and 2 thumbs. As a result, we tend to use a number system which is based on tens. That's a particularly bad choice because 10 can only divide by 2 and by 5. There are a couple of suggestions for alternatives. The usual suggestions are either to use a hexadecimal system of 16 different digits, obviously we don't have 16 fingers, or to use a duodecimal system of 12 digits. The reason the 16 is chosen is because 16 is easily divided into 8, 4, 2, and so forth. The reason 12 is chosen is because it has even more factors. 12 can be divided into 2, 4, 3, 6, and of course 12. Now, the objection that people usually make to this is that we don't have 12 fingers. However, we do have 12 finger bones, and it is possible to count in this manner. There's a hand. That's naught. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's easier to do things this way because there are more factors. Each finger has 3 bones, therefore adding 3 is simply swapping the same bone on different fingers. Adding 4 is going 1 bone up a lot of the time on different fingers. Adding 6 is going 2 fingers across and going to the same bone. You then use your other hand to represent numbers up to 144. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. 13, 14, 15, 16, 17, 18, and so on to 24, 36, and so forth, up to 144. So each bone represents a step of 1 unit on one hand and 12 units on the other hand. You can also count in binary on your fingers, of course, and you can count up to 1024 that way by going like that. So that's 1024, 1023, and so forth. But it's easier to use the 12 system. You can also use the 12. The advantage of the 12 system is it makes more patterns and there are fewer recurring decimal fractions. So, for example, there are patterns for the multiplication tables for 3, 6, 2, 4, and then counting down from 11, and obviously 12. There are also patterns without recurring decimals using decimal or duodecimal fractions, the system being known as a duodecimal or dozenal system. Those patterns are, there are single duodecimal figures for 2, 3, 4, 6, and 12. With the decimal system, there are recurring digits for 3, 6, 7, and 9. As a result, it is much easier to use the duodecimal system than it is to use the decimal system. It's also possible to use the English language to count in this way by using the terms dozen, gross, and a slang term from number theory, Zagia, because of a particular proof in number theory which involves the number 1728. So 12 is a dozen, 24 is 2 dozen, 30 is 2 dozen and 6, or 2.5 dozen, and so forth. 144 is a gross, and a Zagia is 12 gross, also known as a great gross. You can then go square zagia, cube zagia, and so forth to go up to higher orders of magnitude.